Hello and welcome to this section of the TI-89 calculator tutor. Here we are going to talk about zooming and tracing the graphs that we make here with the calculator. And in fact, we've been using the zooming functions quite a bit here in the last few sections, and we've actually used some of the tracing capabilities in the last few sections on graphing. But I wanted to put together a section that has all of the zoom modes and the tracing functionality in one section, just to make sure that nothing slips through the cracks and that you see all of them, because I really wanted to have it in one central location for you, because this is the kind of stuff you're going to use all of the time with your calculator. So to do that, let's go put a function in the y equals. Most of the time today we're just going to use the simple y equals x squared because it plots pretty quickly. It's a simple function everybody knows, and but everything that we're going to say applies to any function that you would graph here. So don't forget the calculator default zoom mode when we go to window here is +10 -10 for x and y. So let's go into the graph and watch it do its thing. And so here we have a nice parabola. So if you have absolutely no idea what the shape of the graph is that you're trying to look at, just go ahead and graph it normally with the default zoom and figure out what to do after that. So let's say we want to zoom in. We have the zoom menu up here. I know we've been using that quite a bit. We have a lot of different zoom functionality, and we're going to go line by line down each one in order, just so that you can understand how to use them. The first one is zoom box, and we've used that one a few times already. It's exactly what it sounds like. You draw a box on the screen with your arrow keys. Let's say we want to look here at the bottom. We have to first put one corner of the box, so we hit enter. That anchors one corner. See, now it's a blinking square. We go over, right, and let's say we go down, and you can actually see right on the screen a nice box form. We hit enter to define our second anchor point, and everything else was calculated for us. The graph begins to plot, filling the window up based on our zoom mode. Now if we go back here in the window, the numbers here were +10 -10 a minute ago. Now they've totally changed. That's because we've anchored down what we wanted these values to be by drawing our box. So that's what the calculator did. All right, let's go back and look at the graph. Let me go back. I'm going to cheat a little bit here. I told you we were going to go and do things in order, but let's go here to zoom, and let's go hit zoom standard. When you hit number 6, zoom standard, that automatically pops you out to +10 -10. It's the standard default thing. So if you zoom in too tight, or sometimes you might draw 3 boxes in a row to zoom in really tight on something, and you want to pop yourself out quickly rather than going to type it all in, just hit number 6, zoom standard, and then you're going to get back out to normal. And I wanted to do that so that I could be back at a starting point to teach you the next zoom mode. So here we're looking at our parabola again, normal zoom. We can use zoom box to go around and look at anything on the graph that we want. The next one just simply says zoom in. So when you hit enter here, it's not going to do anything right away. It's going to ask you for a new center point. Basically, you can put this anywhere you want. So if you know, for instance, that you want to look somewhere over here and you don't want to draw a box, but you know that you want to look over there, just do zoom in, put the cursor wherever it is you like to go, hit enter, and then the calculator is just going to use that at cursor point that you defined as the center of the screen, and it's going to zoom in by a factor here. And I can keep doing it over and over again. I could go zoom in again, number 2, and I say, okay, well that looks good, I want to zoom in even more. And you can keep doing this over and over again until you get as up close and personal with whatever it is you'd like to see. Notice the curved parabola is looking more and more like a straight line, and that's because we've zoomed in so tight. Okay, so that's how you zoom in using the number 2. Zoom out works exactly the same way, but going in the opposite direction. So it's going to ask you for a new center. If I pick it right here, then this is going to be centered in the screen. And the same sort of thing is going to happen when we draw our graph. Now let's go back up here and do zoom out, number 3. And let's say I'm tired of zooming out from there. Let's say I want to go down towards somewhere toward the bottom of the graph here. So when I do that, let's say I pick something like this. It does not have to be on the graph. It could be anywhere on the screen. Hit enter, and it'll use that as a center point there. There for the graph. And notice that the graph is more or less centered because I kind of chose the bottom of the graph there. So that covers zoom box, where you define a box. Zooming in, zooming out, just putting a point on the screen, and the calculator is going to zoom into that point kind of like a camera. The next guy is called zoom decimal. Zoom decimal. This is kind of interesting. Let me show you what happens here. Before we do that, let me go ahead and trace this graph. And we've done tracing before. F3 is trace, so we hit F3. And now we have a blinking cursor on the graph. And as we move our arrows left and right, that cursor is locked onto our graph, and it gives us points along our graph. So it's great for finding intersection points, or just generally if you need to get a table of values or something. It's really good. But notice that all of these guys are oddball decimals, 1.89873. 1.64557. You see, these numbers arise because of the way the guy was graphed, the x and the y values, and so it kind of, in the number of pixels on the screen, it kind of locks in the values of x that the function is going to use to plot your graph. But if you go up here and you hit zoom decimal number 4 and hit this guy, then it will automatically adjust the x and y axis so that when you hit trace, notice that I'm at x is 0.1, 0.3, 0.5, 0.7, 0.9. So you see, it changes the scale so that the x values that it's choosing to display on the screen are nice little decimals, which is actually really nice depending on what you're trying to do. Maybe you're trying to make a table of values. It might make a whole lot more sense to do this and write these values down than it would be the default zoom where you had, all those decimals to write down. So you're looking at the same function, it's doing the same math, it's just adjusted the screen so that the values of x that it uses are nice decimals. And that's a nice thing. So we've covered zoom box, zoom in, zoom out, zoom decimal, which is merely just changing that window guy, the window x and y, to make nice decimal values for our graph when we trace it. The next one is zoom square. The best thing to show you, or the best way to show you what that means, is not to use a parabola. I want to draw a circle on the screen in order to show you what zoom square really does. It's better to do it that way. If you recall, the equation of a circle is x squared plus y squared. If it's centered at 0, x squared plus y squared is equal to r squared, where r is the radius of the circle. And in that case, it's centered at 0, 0 at the origin. So if we want to solve for y, then what the answer is going to be is the square root of 25 minus x squared. And if you look at this long enough, you can see that this is the same thing as x squared plus y squared is equal to r squared. Here, r squared is 25, so the radius of this circle is actually 5, because the square root of 25 is 5. If that doesn't make any sense to you, then just trust me here. This is graphing part of a circle. Actually, it's the top part of the circle. So if we put this in here, let's go take a look at the graph and see what it looks like. And actually, I neglected to go off and change it back to the default zoom. So let me go back and do that. Go to zoom standard. So if you were just turning your calculator on out of the blue and graphed half of a circle, this is what it would look like. So you have the top half of a circle here. Now let me go back in just for kicks, and we'll do the other half of the circle. Now here's a great opportunity to show you something really useful. The bottom half of the circle is the negative of this guy, because when you take a square root like this, it's really plus or minus the square root of whatever's under here. So in order to get the bottom half, the mirror image, it's really multiplying every value here that we calculate times -1 to get the bottom ones here. So it's plus or minus the square root. So instead of typing the way you would really do it, I guess, just to show you in all of its glory, if I wanted to really get the bottom half, I could do negative square root of 25 minus x squared. All right. If I plot both of these functions like this, the top one here is going to graph the top part of the circle. The bottom one's going to graph the bottom part of the circle. So I could just totally do that, but I'm going to take this opportunity to show you something even more interesting. If you just come in here and say, well, really this is negative square root of all this business, but that's the same thing as saying a negative y1, right? If y1 is defined to be this graph, then I can define one of these other graphs in terms of y1. So yeah, I could type all that stuff out. That's totally fine. There's nothing wrong with that. But if you know that another graph that you're going to plot is just going to be, y1 multiplied by something else, then you can literally write it that way. Negative y was up here, and then just press the number 1. And you have to make sure and say negative y1 of x, like this, so that it mirrors the exact same thing, because what we have here, this is y1 of x is equal to this stuff. Down here, y2 is equal to negative y1 of x. So it's just a shorthand way of referencing a function you've already typed in. So we can do it either way. Let's go ahead and leave it like this and go back to the graph, and we'll watch what happens. So the top part of the circle is graphed as we expect. We already looked at that. The bottom half of the circle is the negative of the top half. So we'll start to see these guys piling down below, and it's the mirror image, because literally it is like taking the top graph and multiplying every value that we got times negative 1, which flips it over onto the bottom. So we talked about the fact that this is a circle. The equation of a circle, x squared plus y squared, is radius squared. And we set the radius equal to 5. So we see 1, 2, 3, 4, 5. So yeah, the radius is 5. But this doesn't look like a circle. It looks like an oval or an ellipse. And frankly, the reason why it looks like that, because when you look at it, this is 10 tick marks, 10 plus 10 minus 10 for x, plus 10 minus 10 for y. So why is it shaped like an oval on the screen if it's really a circle? The reason is because the screen is physically longer in this direction here than it is in this direction. So everything that you graph is really going to be stretched out horizontally a little bit if you graph plus 10 minus 10 on x and y, simply because the y-axis doesn't have as much room as the x-axis. So that's a long way of saying if you're graphing something with a circle in it and you want it to actually look like a circle, then you go to Zoom menu, change it to Zoom Square. And you'll see what that means in a second. Hit number 5, it'll recalculate, and basically it'll put different values for x and y, and now it looks like a circle. And the bottom half will fill in a second. Now I want to stress to you that it's just a cosmetic thing that's going on here. In other words, this graph of this circle is every bit as accurate from a math point of view from what we just looked at a second ago. In other words, I go in here and trace and start looking at values along the circle. I'm going to get mathematically valid answers based on the equation I typed in. If I change it back to Zoom Standard and trace along it there, I'm going to get mathematically correct answers. It's just changing the way it looks on the screen. So it's basically cosmetic. You're probably not going to use Zoom Square unless you're really graphing something circular or something that you really want to see, see it drawn in its true shape. So keep that in mind. It's not something you use that much, but it could come in handy, especially if you're graphing a lot of circles or spirals. All right, let's go ahead and take this opportunity to go Zoom Standard and pop it back out, just like we have done before. And we'll see the top graph come here back to our circle, but it really looks like an oval, and then our bottom guy here. And we'll just continue going through the graphing modes there. Underneath Zoom Standard is actually something that we've used also, and let's go take a look at what that is here. Under Zoom Standard, we've talked about Zoom Trig in a previous lesson here. The best way to illustrate that is go back into the Y menu, clear this guy out, and let's go ahead and put a trigonometric function here. Sine of x. Let's go ahead and take out one set of parentheses here. So there's sine of x, and we're at Zoom Standard, so let's go ahead and watch the graph of sine of x. So it's looking like a sine wave. It looks more or less what you would expect to see coming out of a sine. The only real problem with it is, number one, it looks a little bit squished vertically. It doesn't have a nice arc to it like you normally see in the textbooks when you plot a sine function. The other thing is, if you trace it, all of these numbers are correct, but don't forget we're in radian mode here. So what I'm seeing here for x is radians, and what I'm seeing for y is sine of this angle in radians. So as I go along, all these numbers are perfectly valid and reasonable. It's just that most of the time whenever you plot trigonometric functions, the x-axis, a lot of the angles that you're probably going to be interested in are going to be nice angles like pi over 2 radians and pi radians and 2 pi radians and nice multiples of pi. And of course, since this is plus 10 minus 10 everywhere, it has nothing to do with nice integer multiples of pi. So the way you should do that is come in here down to number 7, Zoom Trig. So when we hit that, two things happen. Number one, it changes the Y scale so that we have something that looks more like a sine. But probably the more important thing is when you trace it, you still get these decimals and everything, but this tick mark right here. Let's look at this tick mark. When we get up to the top of this guy, it's a little bit hard to see. So let's take an opportunity here to go zoom box and show you what I'm talking about here. We'll just go ahead and set this guy here, and we'll just kind of look at one little bit of this guy here, because I want to show you what's happening right here at the top. So we'll hit enter, we'll let it regraph it, and notice that the very top of this sign is exactly where the tick mark is right here. So if we go trace it and look at it right there, ask yourself this question. We would have to zoom in one more level to see. This is actually, if you got exact, it's 1.57, which is pi over 2. That's the punchline. So to illustrate this a little bit more, let's go back to zoom standard and let's see how it handles it when it's in zoom standard. And then when we're done, we'll go back and make it go to zoom trig again, and I'll be able to show you a little bit better what's going on here. So let's go zoom trig, and let's watch the guy come back. So it looks a little bit more like a nice sine function. Basically in zoom trig mode, this is pi over 2. This is 2 pi over 2, which is just pi. This is 3 pi over 2. This is 4 pi over 2, which is 2 pi. This is 5 pi over 2, 6 pi over 2. So you keep counting in terms of multiples of pi over 2. So it's very useful because a lot of times when you're graphing a trig function, let's say it was a more complicated, trig function, sine of x plus cosine squared of x or something, then it would have an odd shape. But knowing that these tick marks are pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is very, very useful. The tracing is going to still give you decimal values of this, but you will know for sure that the top, this is 1.57, which is pi over 2, and then when you got down to this x crossing here, it's showing as 3.01 because I'm zoomed out so far, but if I zoomed in tighter, you would see it as 3.14, and that's just really nice whenever you're dealing with trig functions, hence the name zoom trig. Okay, so that's about all I wanted to say about zoom trig. Next I want to talk about zoom int, zoom integer, and that's something that's probably better illustrated by a simple parabola. So let's go back to x squared. Let's go back to zoom, and let's go zoom standard, right? And let's watch this nice parabola be graphed. We've seen this guy being graphed so many times. Notice that when you trace it, just like before, you get these decimals everywhere. Now if you go into zoom and hit zoom integer, it's going to change the scales of x and y appropriately, so you'll get nice integer values of x. So let's go ahead and choose that as a center, hit enter, and watch it go. So it's very similar to zoom decimal, but you'll see here it's a little bit different. So here's 1, here's value of 3, here's value of 5, here's value of 7. So you see these are nice integer multiples for x. So that's why they call it zoom integer. So zoom decimal changes the scale so you get nice decimal values, 0.1, 0.2, 0.3. Zoom integer changes it so that you get nice integer values of x there. So the only other thing I want to talk about as far as the zoom menu is down below zoom integer. Zoom data is for another kind of plot that we haven't even talked about yet. We'll get to that later. I want to talk about zoom fit, which is really actually one of the more useful things that you'll have. In order to do zoom fit, what you need to do first is go in here to the window menu, and you need to set some values of x up. So let's say you want to look at this function only from 0 to 5. So you know that you want the x-axis to only go from 0 to 5, but you want it to fill the screen with the graph. So you don't mess with the other stuff, you just change the x values, and then you go to the zoom menu and hit zoom fit. So you could go down to zoom fit, hit enter, and it's going to calculate the best scale to set that up for you. So you see it's going to fit the screen, it's going to fill the screen, so that's what it's called zoom fit for. So if you were to trace it, you would see that it's only going to go from 0 to 5 along x, because that's what I've set it up to do. So it goes all the way to 5 and it calculates the value over here. Let me give you another example of that because I think it's useful. Let's go back to the y equals mode. Let's do something different. Let's go x to the third whoops, let's go x to the third minus 2x. So we put this guy in here. Let's go and do zoom standard, just to say if you had a shot in the dark, you put this guy in your calculator, you had no idea what it was going to look like, you're going to have the standard zoom on the calculator. Okay, that's a pretty good looking graph, but notice they have all this extra screen real estate on both sides. It's basically kind of empty, and you wanted to kind of zoom tighter in on this little region here. So just first go into Window and say, okay, let's look at from the x-axis from -3 up to 3. So we're defining the region in X that we want to look at this graph, right? But we want the calculator to basically calculate what to do with the Y value. So we go into the zoom menu and hit zoom, I'll go up here, zoom fit right there and hit enter. And it's going to do that calculation for us, and you'll see that it fills the entire screen here. So it'll draw the axis right there, and everything's nice and fit. Now this is really actually similar to what you could do manually with zoom box. I mean, if you were with the standard graph, if you went up here to zoom box and drew a box around the region that you wanted, it would tackle that for you here. But this is just another way of doing it. You'll find that a lot of times in the calculator there's more than one way to really do something. So before showing you something here on the graph, I do want to go over these really quickly. Zoom box, you draw a box and it zooms in. Zoom in, you just specify a center point and it zooms in kind of like a camera zoom just around the point that you specify. Zoom out works exactly the same way, but it pops you out one level. Zoom decimal just changes the scale so that when you start tracing, you're going to see decimals for the value of x down here, 0.1, 0.2, 0.3, etc. Zoom square is used whenever you're trying to graph circles or spirals or things that you want to actually look like a circle, and it changes the scale so that you get nice circular shapes. Zoom standard pops you out a level. You know, because when you zoom in tight, a lot of times you want to go back to that zoom, to that standard zoom of +10, -10. That's what that does. Zoom trig is when you're looking at trigonometric functions, and it changes the x scale to multiples of pi/2. So you see pi/2, 2pi/2, 3pi/2, which is really handy when you're dealing with trig functions. Zoom integer changes the scale so that you see integer values of x, 1, 2, 3, 4, etc. Zoom data is something we're not going to talk about now. It's more advanced, and it's for a later part of the course. Zoom fit is if you go into the window and specify a region in X and then go do zoom fit, it'll make the graph fit the entire screen. And that is basically completes all of the zoom functions of this calculator. And with all these functions, you can pretty much get anything done. Now, I do want to show you one more thing before we leave, and that is the following. Let's do something like this. Let's do x to the 4th power, right? X to the 4th power. Really steep guy here. Let's go to the standard zoom, which is what I want, and let's watch it graph x to the 4th power. And what I'm going to do is show you a couple of features of the tracing functions here. We've been tracing all day, and you know that F3 does tracing, and you know how it works. But what I haven't shown you yet is what happens when you go off the screen. See, now I've gone off the screen. Here I'm on the screen. Now I've gone off the screen. I'm off the top. Notice the values keep changing. It keeps giving you valid values, but the graph is kind of stuck down here. If you're off the graph and you say, wow, that's kind of interesting, I really want to be up here, and you want it to kind of recenter around that, then just hit enter when you're off the screen, and the calculator will automatically put you up there. Now notice these are almost vertical lines because x to the 4th power is such a steep function up there. But that's basically what's happening here. So it lets you go off the screen like that, and you have to hit enter to make that happen. Now to show you something else, let me change this back to a sign. I'm going to show you what happens when you go off the screen to the left or to the right. So when you have sign, let's go into here and do zoom standard. And let's watch it graph this sign, and we'll see what happens. We'll find out that when we go left or right off the screen, something a little bit different happens. So we'll trace it, and we'll take our sweet time getting over to the right-hand side here. Now notice that once I go off the right-hand side, it starts to push the graph over automatically. So that's the basic difference. If you trace off the top or the bottom, you're going to have to get enter for it to sort of recenter the graph for you. If you trace off the left and the right, it's going to automatically push it out of the way for you. That's basically the bottom line there. One final thing I'll show you. Let me graph two guys. This is a sine of x, and the next one, let's graph x squared. And for the third one, let's graph x plus 2. That's just a line. And let's go back to the graph window and watch all of these graphs pop on the screen. I'm going to show you a little something about tracing, and then we'll wrap up this section. So we have now 3 graphs on the screen, and when you press the trace button, you're tracing the sine here, and you can see it because it's got a blinking cursor, but really what I'm trying to draw your attention to is see the number 1 that popped up here? Let me hit escape. Number 1 disappeared. It only appeared when I started to trace the function. This is telling you I'm tracing y sub 1. That's the sine function. That's what this number represents right here. It's pretty obvious because I'm right here, but if I'm tracing over here, it's difficult for you to see. Am I tracing the parabola or am I tracing the sine? This number tells you that. If you want to go and trace a different graph on the screen, left and right is not going to do it, but you have to hit up or down. So hit the down arrow and it'll change to 2, which tells you I'm tracing y2, which is x squared. So now when I go left and right, let me go and hit trace again, and down again to get to number 2. Now when I trace, I'm locked onto the parabola. I'm not attached at all to the sine. All right? And you might guess if you hit down again, it'll change to 3, so I'll now be on the line. So that's really important whenever you're graphing multiple equations to be able to know to go down. You can cycle through these guys. If you forget which one's which, just go back to the y equals menu and you can see that. Well, that about wraps it up here. We've covered a lot of material, but it's all material that you're going to use all the time with this calculator. I mean, you buy it so that you can graph stuff. It's a shame if you don't know how to use all the modes. So we spent a little bit of time talking about the different zoom modes, of which there are many. But, you know, between you and me, to be honest with you, I mean, there's a ton of functionality. It's great to know how to use all this stuff. Honestly, I use zoom box a lot and zoom standard a lot. Because I find that usually when I'm graphing things, I'm just trying to get a detailed look at an intersection point, or let's say I was trying to see this stuff over here. I mean, I would just draw a box around it and then I would trace and I would be happy and go on my way. But a lot of times when you have something specific you need to do, you need to be able to trace or zoom in a certain way, and it can really save your life there if you're trying to get something done quickly on an exam. So play around with it. You'll get the hang of it. Watch a video a couple times if you need to. And these modes can really save you a tremendous amount of time.